Welcome everyone, I am Parveen Kumar. We are offering here a project. The project title is the Class Imbalance Prediction about the Landslides. First, I will introduce little bit about the landslides. Landslides are a major problem in the India as well as in the world. Landslide causes the major infrastructure damage and deaths. India tops the global landslide list. Landslide is like a plague for the Himalayan region. Some of the Himalayan states like Himachal Pradesh and Uttarakhand are highly affected with the landslide disasters. In India, 200 people are buried alive under the landslide every year. And we could avoid this problem if we could predict the landslide before it occurs. One way to predict the landslide is to predict the soil movement via machine learning models. Here the soil movement is the small movement in the slope of the hills that trigger the final landslide. The objective of this project is to develop the time series machine learning and deep learning models to predict the soil movement in the landslide from the class imbalance problem. Here the class imbalance data means there are fewer data points for one class compared to the other class data points. In this project, we need to predict the soil movement based on the historical value of the soil movements. So basically, it is a regression problem. Now I will introduce the study area. To train the machine learning models, we require the data. The data we obtained from the Tangni landslide in Uttarakhand. The DRDO have installed the landslide monitoring station at the Tangni landslide as shown in figure 2. The monitoring station has the 5 boreholes at different positions and everyone is indicated by the different colors. As can see in the figure 3, each borehole consists of 5 inclinometer sensors at the distance of 3 meter to others. For example, first one is at the 3 meter depth, second one is at 6 meter depth and so on. We obtain the 2 years time series data from these borehole sensors. The working of the inclinometer sensor is shown in the figure 4, where we can see that the sensor installed at a specific position in the borehole. The inclinometer sensor is a biaxial sensor, so it can tilt either in the left or right direction. If it will tilt to the left, then it will produce the positive reading, and if it will tilt to the right, it will produce the negative readings. So here we are measuring the angle of tilt of the inclinometer sensor, which is basically a soil movement on the slope of the hills. In total, there were 25 sensors in the 5 boreholes. Out of 5 sensors in a borehole, we choose only one sensor that shown the maximum angle of tilt over the 2 years. So in last, we have 2-year hourly time series data from the 5 sensors. The soil movement data was very sparse. There hardly had some movement, so make it dense. We converted the hourly data set to the weekly data set via averaging the soil movement data in a week. As a result, we came up with the 78-week soil movement data from the 5 boreholes. We have divided the dataset into 80 to 20% ratio for the training and testing of the machine learning models. The data from the training is shown in the figure 5. The figure 5 showing the negative and positive movement, where negative movement means landslide slope move downside of the hills. The soil movement in the landslide is a rare event, so our dataset have few soil movements data points than the non-movement data points. So this caused the class imbalance problems. This table showing the soil movement data from the 5 different boreholes. Here negative readings showing the sensor tilted to the right direction and the positive readings means the sensor tilted to the left direction. Our problem is a time series regression problem, so we need to predict the next week soil movement value based on the previous week values. For example, we could utilize the week 1 to week 10 soil movement time series data to predict the week 11 soil movement values. There are some models that we could suggest to solve this time series problem like autoregressive integrated moving average model, Holt-Winter model. These models could find the autocorrelation in the historical data and predict the next value. And the recurrent neural network models like LSTM also works very well on the time series data. Thank you. If you are willing to join these projects, then please drop a mail to on this following email ID.